In this video, we're going to be starting our factoring set of videos here. How do we factor polynomials? That's where we're at. So we factored some quadratics. But how do we factor expressions that have a higher power than 2? Well, those are any polynomial. And we'll learn how to factor anything that is greater than a power of 2. One technique is called grouping. And this is how grouping goes. Let's get a really easy example here. If I have 6 plus 9 plus 8 plus 12. Obviously, because they're numbers, we could add them up. That's pretty easy. But let's do it by factoring. What do these two terms have in common? What's their greatest common factor? 3 is the biggest number that goes into both of them. So if I take that out, I'm left with a 2 plus 3, right? 3 times 2 is 6, plus 3 times 3 is 9. Let's do the same thing over here. What are these two terms, 8 and 12? What's the biggest number that can go into both of them? What can I factor out? Well, 4 is the biggest number that goes into both of them. And I'm left with 2 plus 3 again. So as you see, we have two sets of parentheses with the exact same value. I can write that once, and my final factoring form is going to look like this. So the two sets of parentheses that have the same thing in them are just going to be combined into one set of parentheses. And the leftovers are this number and this number with its sign go in the next one. So 3 plus 4 go in the first one. So if we added all this up, we could get 35. But if we factored it, we still get 7 times 6. Well, that's still, 7 times 5. My bad. There we go. That equals 35. Okay. So obviously, with this example, maybe you think that factoring was a ridiculous way to go. And that's totally true. But it allows us to see what grouping is without getting too crazy. So now let's get crazy with it. Let's factor using this grouping method with a polynomial. So if we have x to the third minus 2x squared minus 9x plus 18. So grouping, usually we're going to take the first two terms here, and we're going to try and take out their greatest common factor. So what goes into both of these terms? What can we take out? Well, x squared is the biggest thing that goes into both of them. And write our leftovers. So x to the third divided by x squared leaves x. That's one way to think about it. 2x squared divided by 2, or 2x squared divided by x squared is negative 2, right? Now check out these last two terms. If I take out 9, I definitely know that's the greatest common factor. And I know that I'm left with an x and a 2, but my signs are kind of questionable. If I take out a negative 9, well then I'd multiply by a positive x and a negative 2, right? Because negative 9 times negative 2 would give me the positive 18. Negative 9 times x would give me the negative 9x. And now you can see that our two sets of parentheses have the exact same values in them. So sometimes you're going to have to play with that sign a little bit just to make sure that these two parentheses match up. So what we write in our first set is our x squared, these things on the outside, x squared minus 9. We put them together in one set of parentheses. And then our set of parentheses that got doubled here. So we put that there. So this is our final factored form. Oops, sorry, not our final factored form. This would be our grouping factored form, right? But if you take a look right here, hopefully this is familiar. This is a difference of squares. So now we use our quadratic factoring pattern. We know we got two sets of parentheses with the roots in each one. And our difference of squares factor pattern says that one gets a minus and one gets a plus. We still have this x minus 2 left over that we didn't do anything with. So this is our final factored pattern. And we would use this to solve for x if we needed to. We haven't gotten there yet, but if we did, we would set each of these sets of parentheses equal to 0, and then solve for x. So as you can see, we're going to have about 3 values, 3 x-intercepts, and we'll get to that later. Let's do another example of grouping. One clue that might help you when you're factoring and deciding what factoring technique to use. Grouping, you're generally going to have 4 terms, right? Because we're going to factor these first 2 terms, and then we're going to factor the last 2 terms. So you need 4 terms to do that. So in general, grouping can be done to polynomials with 4 terms. Okay, so let's factor again. Let's group these. Factor the first 2 terms. We could take out a 4 and an x squared. That goes into both of them. If we take that out, what's left over? Well, an x in the first term and a plus 4 is what's left over. So let's do the last 2 terms here. So you might be thinking, the only thing that can be taken out is a positive 1, right? Well, then write it. Positive 1 is their greatest common factor. Sometimes that's what happens, and we're left with x plus 4, right? Same thing we started with if we're multiplying by 1. Well, you see our 2 sets of parentheses here that have the exact same values. That's our second set. And the first set is what we got on the outside, 4x squared and a positive 1, so 4x squared plus 1. If you ever want to check, obviously we would do foiling to check, and we should get back after we FOIL to the very beginning. But you always want to check before you circle your answer here, can we refactor either of these? Well, you might think that you could refactor this, but this is a positive, so we don't have any factored form that is the difference, the sum of squares. We only have a difference of squares factor pattern. So we can't refactor that. So this is our final grouping factored pattern. So that's grouping, and we'll get to some other methods in later videos. We'll talk about a couple more factoring patterns in the next couple of videos here, and then we'll finally get to solving these polynomials.